Hi, welcome back to my analytics channel. For this demonstration, I will show you on how to write a code implementing abstraction in object-oriented programming. In fact, when you say abstraction, meaning you need to hide the background details of the implementation. And for us to perform this concept, we need to make a separate interface. For example, we will compute the miscellaneous fee. Okay, we will create a constructor to initialize our object and the methods or functions for the computation of the fees and to display the computed total fees. Okay, so let's do the coding of this on how to write an abstraction approach in object-oriented programming. To start with, we need to have our library include input-output stream. Okay, and followed by this using namespace std or standard for our cin and cout. Okay, let's first do our class. So with the keyword class followed by the name of our class, let's say computation, and followed by the closing curly braces with semicolon. Okay, so let's declare our data members as private access specifier for our fees. Okay, so let's say we use double data type for the fees. And for that particular fees to be accessed outside of this class is we need to have a public access specifier for our function. Let's say our function for this, we need first to, before we create our function, we need first to have our constructor. So to create a constructor, we will initialize the object, okay, of our class. So we will have to create a constructor using your class name. Okay, your class name is computation. This is how you create your constructor to initialize your object. Okay, so example, our computation, then this is, we initialize our object and we will use a variable f and we initialize as 0 for the fees. And let's say that fees will be now your f variable will be now your fees. Okay, this is our constructor. Okay, since we have already created our constructor, now we will create the functions or the method for the computation of the fees. Okay, let's say we use the double data type, then we name our function as computed fees, for example. Okay, you can name your function whatever you want. Then we have a parameter here. Let's say miscellaneous fee stands for MF as our variable here, parameter. Then we need to have a computation here. So therefore, our computation here, since we have already constructed our object, we initialize as fees. So we need that one plus equal to f, meaning this particular variable, or so sorry, should have a value. So where do we set the value for this one so that we can pass a value to this parameter? Of course, we need to create our object. Let's say we need first to create our object our name of the class is computation, so you have to use that, okay, and create your object name, example obj. So this is a user defined, okay, object name, so meaning you can name your object whatever you want. Then we have to create our object, and this must return a parameter. Our object must return a parameter. So this is our function computed fees. So we have to computed fees. Then the example, this is the value that we're going to pass to this. This is the value to be passed to this parameter. Okay, then we will add another value, computed fees. Let's say, for example, let's change to 1,000 pesos. This is 2,000 pesos. Okay, so this particular value will be passed here. Okay, then we have another one. Okay, computed fees, sorry. Computed fees, 3,000. Okay, so when you pass this value, okay, here, as you can see, this is 0. So this is how to read this particular expression. Fees plus this particular variable is equal to our fees. So we will pass this one, okay, to here. Okay, for us to know what is this particular value, so you can name that here. See out. Let's say this is your library fee. For example, this is for example. Okay, and you can have this one. And for this particular value, you have, this is your internet fee. Internet fee. Okay. And this one, let's say this is your laboratory fee. Laboratory fee. Okay, so we have the name of this parameter. Okay, the value of our value. Then, of course, we pass these values to this particular parameter, and it will compute, right? Then we need to create another interface. Okay, it's a double two for the total. Double total fees. The name of this one's total fees. Then this is our function to for our fees. Okay, and since we need the value for this, we need to have this return. Okay, and this one return. Okay, okay, before we run it, let's incorporate this one. Post greater 0. Okay, and since we display, okay, this one, this one, okay, and this particular method or function will compute, okay, this values. So therefore, if this is 1,000, 2,000, so this total is 6,000. And we make a separate interface for the total fees. This is how the way we implement the abstraction. As you can see, so we separate the interface of each uh, details, okay? Then, of course, we have to make this total fees. Okay, Then we will call this particular, okay, function. So object name total fees, like that. Okay, so let's review again. Sorry, this one. Okay, let's add another formatting set precision for the decimal places of our value. Okay, since that is in red line, meaning you have to include this library. Okay, so then you copy this one for the other part of your value here display. Sorry. Okay, so let's try to run first this code if it is working, as you can see. But before that, we have to review this code. We have our class. The name of our class is computation. Then after we did this class, as you can see, we create an object name of our class, computation. Then the name of the object is obj. Then, as you can see, we create our data member, okay, as private for the fees. And since this is private, it cannot be accessed, okay, from outside this class. And for this fees to be accessed, of course, you have to create a public function. This is similar to encapsulation. Okay, so we have this one. Okay, we have a private access specifier for our fees. So this can be accessed only in this class. You can access this particular member through its public functions here. Okay, so we have our parameter here. Then what is this parameter? This is refers to this particular object because we set the value here and pass to this parameter. Okay, this one to here. So this is our function to compute this fees. Okay, the 1,000, 2,000, and 3,000 because this is our expression. So to read this fees plus the this variable, this parameter, this is mf, okay, is equal to fees. Okay, then this is our function to display the computed total fees. So we did some abstraction here. Then this is our main method. Okay, we label it. Okay, we label each of our object with the parameter. Okay, then that's it. Then let's run this code. What happened? Okay, so we have what happened to laboratory fee and total fee. So you have to, okay, forgot to include new line there. Okay, so let's run it again. So since we apply some modification of our code for the formatting, so let's run again. Okay, so this is it. This is our code. So as you can see, so we successfully run this code. Okay, so that's all. And thank you for watching. I hope that you learned this simple demonstration about object-oriented programming abstraction approach.